Imagine you build an application. On day one, you have 100 users, everything working perfectly. Then one day, a famous influencer virals your app. Suddenly, the 1 million people are trying to use your application at the same time. Your database starts crying, your server stop responding, users gonna see lot of errors, and within in minutes, your application is dead. But somehow, you will observe that apps like Instagram, ChatGPT, they survive these traffic spikes from millions of users every day. How? That's exactly what we are going to learn today. By the end of this video, you will understand the complete scalability concept used by every modern tech companies. So let's begin. So let's understand what scalability is. Can your system handle growth without breaking? Now, growth can be in multiple ways, right? You will have more users, you will have more requests, more data, more transactions. And to measure scalability, what engineers basically use metrics like requests per second. What are the number of concurrent users? What is the throughput? Throughput is like somehow related to concurrency and the request per second. The data storage volume, more users, more data, right? So let's take a very simple example. A system handling 100 requests per second today might need to handle 1 lakh requests. So question is, can it grow smoothly? So that's where the scalability comes into picture. Now you can scale your system in two fashion, what we call as vertical scaling or horizontal scaling. Let's talk about vertical scaling. It just simply means best buy a bigger machine, more CPU, more RAM, more storage. But there's always a limit to that. There's a ceiling. Like you can't keep buying bigger and bigger machines forever, right? There has to be certain limit. At some point you will hit a ceiling. So that's the limitation. And that's where we come into the second type of scaling, that is horizontal scaling. Instead of buying one giant machine, right, you can add more machines, one server, 10 servers, and now the traffic gets distributed. So this is where most of the technologies or companies or tech giants use the technology of horizontal scaling. There's always a trade-off, like you have to do like when is vertical scaling beneficial and when does horizontal scaling. But the disadvantage or only restriction with horizontal scaling is that your servers must become stateless. Now, what I mean by stateless? There are two types of services. One is stateless and is stateful. Stateless means they do not care about the session data. So suppose you log into your Instagram, a service will only respond if it has the service data, your login data. But you can't store the service data connected to each server, right? It has to be a common primary database where your session data is stored. So suppose you log into an Instagram, request one goes to server A, request goes to server B. Now how does each server know that you are logged in? So if session information exists in only like server A, the other servers will be clueless. And that's why this is called a stateful architecture. So it does not scale well, right? The solution is store the session data in somewhere in the central. That's where we come use Redis and all those cache mechanisms. Now, in the architecture of system, like there are different ways of scaling the different layers. So we'll talk about each of them. One, we have the application tier. So we are saying that let's start that. Imagine there's a restaurant. One waiter can serve only a few customers. But as the customer increases, you hire more waiters. So the application workers work the same way. More traffic, add more servers. But how to distribute the traffic? That and for that we use load balancer. And because servers are stateless, any server can handle any request. And this is the easiest way to scale. Next, we have to scale the database. Now, this is the craziest and the a little hard part, right? Databases. Unlike application servers, you cannot randomly scale because database consists of the critical data. You can't simply copy it, right? Consistency matters. So that's where we will. So to scale the databases, you can do two ways. One is create the read replica. the most applications perform more reads than writes, right? For example, Instagram uses read posts for more than rather than create posts. Think of yourself, right? You create more, you rather than creating more posts, you mostly acquire read the data, right? So we keep one primary database and multiple read replicas. So the writes goes to primary and the read goes to replicas. Now this reduces the pressure on the main database. So suddenly the one database becomes many and the read capacity increases dramatically. But eventually even one database becomes too large, right? So now we have to split the data. Now this is what we call the sharding. So instead of one giant database, we will have multiple databases. Like database A stores some users, some others in B and some others in 3. And there are different mechanisms to distribute this data. So three commons are like range based, right? Like 1 to 1000 will go to database A, others to database B, something like that. Then we could have hash based. Hash based, like you use some hash function and automatically decide where the data lives. Then we have directory based, and in case of NoSQL databases, this is like inbuilt mechanism. Like you do not have to something do manually to do that. It automatically shards the data based on the volume. And with the sharding, there comes the concept of consistency, right? There is a concept of eventual consistency and strong consistency. Suppose you have a lot of read replicas, right? And suppose you write in the primary database that needs to be replicated across all. So you want strong consistency. The moment you write in the primary, it should be replicated in all. That is strong consistency. This is usually required in case of payment systems, right? But in case of like other, suppose you post some data and it may not be replicated immediately, it's fine, you won't see post, sometimes it's not a big damage, right? So then you can have eventual consistency, that eventually they all will be consistent, but eventually even talking about some seconds, because and in strong we want not even a millisecond of lag. Next we have the caching tier. So caching tier is, let's talk about, this is the one of the most biggest performance boosters in the system design. Think of cache as a short-term memory. Suppose a celebrity uploads a post. Now millions of users are requesting the same content. Now without cache, every request hits a database, right? Database will suffer. So now with cache, data gets served directly from the memory, which is dramatically faster. Technologies like Redis make this possible. And Redis clusters automatically distribute the data across nodes using techniques such as consistency hashing. So this will reduce the database load and improves the response time. Next, we have the message queue. Now imagine a user uploads a photo. The system needs to store the image, generate thumbnails and notifications, a lot of tasks lined up together. Should the one user wait for all these tasks to complete? Absolutely not. Instead, the application drop tasks into a queue. Example, Kafka, RabbitMQ. The user gets the immediate response, but meanwhile in the background, workers process tasks at their own pace. Now queues what help? They help in removing the bottlenecks, they reduce the dependencies, and they help the make system resilient under heavy load without making each process independent of each other. So this is the example which I am talking about. So let's combine everything together. What I taught. When traffic grows, step 1, scale the application servers horizontally. Step 2, add the read replica. Now the volume is increasing. Step 3, shard the databases. And now if you also want to improve the performance, introduce the caching to store the data in the memory itself. And for asynchronous work, use message queues. Now this is the foundation system behind Instagram, Netflix, Uber. Different companies use different technologies, but the principle that we learned today remains the same. So today we learned about what scalability means, vertical versus horizontal scaling, stateless services, read replica, sharding, caching and queues. In the next episode of ScaleKraft, we will dive into one of the most important concepts of system design, availability, and other concepts that follows that, like reliability, durability, and all those stuff. Subscribe to ScaleKraft, and I will see you in the next episode.